Hey Precalculus, so we've started a new chapter. We're going to be talking about exponentials and logarithms in this chapter, and today we're focusing on exponential functions. So to begin with, let me give you a definition. An exponential function is anything to the form f of x equals a to the x power. Okay, so anywhere you have the variable you're inputting in the exponent, it's going to be an exponential function. So an example of this might be like y equals 2 to the x. This is a classic exponential function. Or y equals e to the x would be exponential. Or y equals 3 to the x. Basically, any real number raised to the x power is automatically an exponential function. Now, these exponential functions all have different graphs, and you can find those graphs using an xy table. And we can shift these graphs just like we've always shifted. So the general way that we would shift is we would say y equals, I'm actually going to say a times, let's make this a b instead of an a up here in your notes. Go and change that, please. A times b to the x minus h plus k. And just like normal, this a is going to be a scalar. It's going to make your graph get taller or flatter. And the h and k here are going to shift your graph left to right for h and up or down for k. And we've got some key points on these graphs. Hi. Our key points are going to be, if I plug in 0, and there's no h and k here, what you're going to get is b is 0, anything to the 0 power is 1, and so that's just going to leave you with a, so 0a, and 1ab, because if I plug in 1 with no h and k, then I would have b to the first, and b to the first is b, times a is the point ab. Okay. So an example of this, example 1. Okay. If I gave you y equals 2 times 3 to the x minus, 4 plus 5. I'm just picking numbers here that are easy. Okay. If you're going to graph this by hand, what you would do first is write down your key points. So 0a, which for us would be 0, 2, and 1ab. So 1, let's see, a times b is 2 times 3, which gives us the point 1, 6. So we have 2 key points here. What that means is our graph initially, before I do any of these shifting, is going to have a point at 0, 2. So let's say I'm going to go each half unit. So 0, 2. And over 1, up 1, 2, 3, 4, 5, 6. And these exponential functions get bigger and bigger and bigger. They get big fast. And on this side of the axis, they're actually going to approach a horizontal asymptote at 0. So this is sort of the general shape of your curve, right? And then if I'm going to shift this curve, let me grab a different colored pen. This negative 4 is going to shift it to the right 4. Remember, you go the opposite of what you think it would do when it's with the x. And this is going to make it go up 5. So each point would go 1, 2, 3, 4, and then up 1, 2, 3, 4, 5. So that's where that point gets shifted to. This one goes over 1, 2, 3, 4, up 1, 2, 3, 4, 5. Okay. My horizontal asymptote used to be at 0. It also gets shifted up 5. So 1, 2, 3, 4, 5. And it's horizontal, so I'm going to draw it out flat. There's the line y equals 5, my asymptote. Okay. And then I would draw my curve in. Okay. So if you're graphing by hand, the first thing you're going to do is find your key points. After that, you're going to graph the shifts. And make sure, please, to include your horizontal asymptote at y equals k. So in this case, k was 5, so it was at y equals 5. In general, it'll be at y equals k. So there's a little bit of graphing by hand. Some other things you need to know about exponential functions. You need to know about this e character. I know you guys have seen it before back in advanced algebra. So in your notes, would you please add that e is Euler's number. Okay. So this e is a special number. It's kind of like pi or the square root of 2. If you were to grab your calculator, and on your calculator you find the e right down here above the ln key. Okay. So what I'm going to do on my calculator is hit e. Oops. I have to hit the second key. Second and then ln will give me the e. And then if I raise it to the first power, oh, it's not the 11th power. There you go, e to the first, right, on my calculator. And hit enter. You're going to see that e is defined by 2.718281828, and it goes on and on forever. This is one of those decimals that keeps going on and never repeats itself. I know you see a little bit of repetition in here, but the numbers are going to change up after this if you had a calculator that would go out farther. E is approximately 2.718, we'll say, we'll go out to 3 decimal places. It's Euler's number. It is an irrational number, meaning that it's a decimal that goes on and on forever and never repeats. And it's special. It's one of those things that comes up really often in all sorts of problems in nature. And it's one that we'll see a lot when we start working on story problems in this section. The way that you get e is you take 1 plus 1 over n, and you raise that to the nth power. And as n gets closer and closer to infinity, as you plug in bigger and bigger numbers for n, this thing is going to get closer and closer to e. It's going to approximate it better and better. Okay? So something that you need to know. Now, in terms of how big e is, since it's about 2, it's between 2 and 3, before, when I wrote up these 3 graphs, y equals 2 to the x, y equals e to the x, and y equals 3 to the x, what you should see on these graphs is that it's going to sit between 2 and 3. So let's see. Let's call this guy example 2, since I didn't give it a name. And so in example 2, go ahead and graph y equals 2 to the x, e to the x, and 3 to the x. Now we can do this like we did with our key points. So I'm going to get the key point 0a, so 0, 2, and 1ab. So in this case, we've got, oh shoot. So y equals a times b to the x. So 0a, oops, sorry, this should be a 1. Because if I plug in 2 to the 0 is 1, and 1ab, there we go. And I'd have 0, 1, and 1ab. And 0, 1, and 1ab. There we go. Okay. So when I graph these, I go over 0 up 1 for all of them, and then 2 to the x goes over 1 up 2. Let's see. E to the x goes over 1 up e, which is about 2.7. And 3 to the x goes over 1 and up 3. Here. And so what you see, you still have your horizontal asymptote at 0. So there's 3 to the x. This guy also goes through this point, but it's not quite as steep. There's e to the x. And then 2 to the x goes through 0, 1 also. And again, is not quite as steep as 3 to the x. Okay. So 3 to the x just grows faster than the other ones. Let's see, some other things that you need to know. You're going to need the formulas here soon for periodic and compound interest. So let's call this example 3 in your notes. So periodic interest follows the formula A equals P times 1 plus R over N to the NT. We'll talk a little bit more about this in class tomorrow. We're going to do some problems like this. The A is your ending amount. The P is called the principal. It's also your starting amount of money usually. The R is your interest rate. The N is your compounding period. And the T is time. And it's usually in years, but not always. Okay? And then so this is when interest is compounded like once a year, twice a year, 3 times a year. If it's continuously compounded, then we follow the formula A equals P times E to the RT, where A is still your ending amount, P is still your starting amount. Now we're using Euler's number here in this formula, and we have to the RT, where R is your interest rate and T is your time period. So just some formulas to get down on your paper that we'll use tomorrow in class. All right, guys, that's it for notes tonight. Please check the blog for your other part of your assignment, and have a good night. Thanks.